hear you
You cannot hear me? Why? That's
properly.
bad.
I'm
Oh,
sorry. I mean properly.
is it okay now? Can you hear me?
No, it got worse.
Is it the same for everybody else?
It's not
Yes,
at the best.
sir, I can hear you, but we are
Okay.
good maybe.
It's very muffled for me.
Okay. It is? Okay. I don't know why this is happening. It usually doesn't happen like that. Okay. Let's basically see if it because I connected to an external one. Okay. Understood. All right, kids. Mush, you can rejoin if you want to. Okay.
Sir, it's muffled to me as well.
I meant to say that your voice is like muffled and we can't hear you clearly. I can hear you but not clearly.
Okay. Can you both rejoin, please? Okay. Or it's me only. Wait a second, I'm checking it out. What's the issue? Okay. I think it could be because of my microphone as well. Can you remove that? Is it any better now?
It got even worse.
It's
Wow, that's bad. Wait, let me rejoin that. All right, now what do you say?
Yes, much better.
it's bit better.
Okay. All right. I think it was an issue with the network of my tablet. Anyway, so I'm going to start now. Last time we discussed about, if you guys remember, sine I or sine R, refractive index and stuff. And then I said we're going to talk about critical angles. Now today our main purpose is to see this one. Now critical angle is basically an angle of incidence, at which 90-degree refraction takes place. Now, to find this interesting angle, we got to use sine of C equals to 1 upon n. Now, what is that? Let me just explain it to you one by one. This sine C is the critical angle, and this n is the refractive index. All right, kids.
Yes, sir.
Now, we have three conditions right now. It's basically we have three semicircular blocks. All of these are made of glass and air is outside. All right, kids. So let's suppose if you have a ray coming in, so from the rounded part, it will just go straight. But then you have to draw a normal line. A normal line, this will be the angle I. And because this is the angle I, whenever something goes from more to less, then it bends away from the north.
Sir,
You
it's
guys agree?
muffling.
Oh my god, that's not fair. Right? Yeah. Right. Why is it doing like that? That's not fair. Very, very strange. Let me check with the other one. Okay. Yeah, I understand. There is some network issue going on today. That's bad. Doesn't usually happen. We have a very good internet. Anyway, is it okay now? Okay. So what I was saying that if you go through an angle and obviously generally what happens is it goes from glass to air, so it will be like bending away from the normal that we've learned already. But then, kids, you increase the angle to an extent where at a certain angle where the ray is going to completely bend 90 degrees to the normal, like that. This is where this angle I will be equal to the critical angle. Is that clear, kids?
Oh, yeah.
Yeah, it's clear.
All right. Then what happens is, if you further increase the angle beyond critical angle, so you draw a normal line. So at that angle, then the ray, instead of going out, will be reflected inside at the same angle. And this phenomena happens when the angle of incidence becomes greater than critical angle, and that is called the total internal reflection. Now remember again, if the angle of incidence is less than critical angle, it would just cause the normal refraction that we learned. If the angle of incidence is greater than is equal to the critical angle, it causes a 90-degree refraction. And if the angle of incidence becomes even larger than critical angle, the ray, instead of going out, will come back inside. Any questions now? Please let me know.
Nope.
All right, kids. So I want everybody to write this down, and then we shall go forward. Okay. Should I go forward, please?
The last diagram.
Okay. Is there somebody who's new? Amos, Mazhar, I don't know you. Amna,
Yes, sir.
Rizwan, I.
Yes.
Okay.
Yes,
Amna,
sir.
you're also new?
Yes.
Okay. Well, that's good. So, Amna and Amos, we are following a workbook that all the kids have. All right. So you can go through it right now. You can write the notes, but when you join the class, you will get this workbook. So you can work on it. All right.
All right.
Okay.
Okay.
Thank you, sir.
Now, no problem. All right, kids. So I'm gonna now go to the next and see what exactly do we mean by total internal reflection. Total internal reflection is a phenomena which occurs when the angle of incidence becomes greater than the critical angle. It is only possible when the ray of light is passing through when a ray of light is passing through a more dense medium to a less dense medium. Remember, total internal reflection cannot take place if it is moving from a low density to high density medium. Is it clear, kids? Kids. It will also always occur when it goes from high density to low. Remember that. Otherwise, your answer will be wrong if you do not mention this. Okay, write it down, please. So then we shall go forward, check out some questions which are very, very important. If you feel any difficulty at any point, please ask. I will be very happy. All right, kids. Yes, yes. Hadia will take. I will explain each and everything. Don't worry. We have everything coming up. All right. All right. Should I go forward, please? Everybody has written it. Tariq's here today. Okay.
Yes.
Yes, he is. Very good. The other Abdullah is not. Sorry, Muhammad Abdullah is here. The other Hassan is not here. Anyway, now let's check it out. This one. So who's gonna help me out here, please? Quickly solve this. It's B. Okay. Right. Let's see what others think. Okay. It's C. Okay. We have some competition in this one. That's good. Very good, Tariq. Very good, Hatia. Very nice. All right. Everybody, I want everybody to wake up, please. Mariam, Amna, Vipesh, Ibad, Mohammed, quickly, please. Hassan, Manur, Marwan, Marwa, quickly, please. Tayyib, very good. Very good. Amna, very good. Afraz, very good. Rabia, very good. Ibad, very good. Marwa. Okay, a lot of people are B. So only one person said C. Okay, let's check it out now. So basically, you guys know that this is the diagram we need to look for. The reason we want to look for this diagram because it shows us critical, the angle that is 44 is basically critical angle, which means we can use sine of 44 equals to 1 upon n. So n will be 1 divided by sine of 44. So let's check it out. I do my calculator. 1 divided by sine of 44. So that would be 1.44. Yes. What did you do? Abdullah? Do you understand the mistake? What angle did you take? Okay. All right. Very good. Now, what do you guys think about this one then? Which row shows the angle of incidence and whether total internal reflection occurs or not? Okay. So C. Okay. Well, I see a reflection.
Yes, it's C.
Okay. It's C. Okay. Very good, Tariq. Very good, Maha. Excellent. Excellent, Rabia. Okay. Very good. Amos, please wake up. Participate. And Usman, wake up, please. Yes, very good, kids. Excellent. Excellent. Very nice. Why can't it be D? Why can't it be D?
It's because that ray changes. It doesn't reflect back. It's refracted. It changes medium.
No, that also causes it. There is a reflection. It is reflection. Okay. Yes, smart. Right. Very. Sorry, come again. Usman is right. You know why? Because I just told you total internal reflection can only take place when the ray of light is moving from a more dense to a less dense. This one is going from air to glass, where air is less dense and glass is more. So that is why total internal reflection is not taking place. That is normal reflection. Is that clear, Mush?
Yes, understood. My bad.
Yes. So always, for everybody, always see if the ray is moving from more to less dense or not. So that's very, very important. All right, kids. Now, in the next one, it says, shows an empty container and the observer I, there is a small point at position O, and the observer is unable to see the coin. Okay. The observer and the coin stay in the same position and the container is filled with water. The observer can now see the coin. Explain why the coin can be seen by observer. So obviously, there has to be something related to bending. What causes bending of light? Can you please tell me that?
Reflection.
Refraction. Very good. Exactly. Exactly. Very good, Vipesh. Very good, Tariq. So what happens is that if it is filled with water, the ray of light is going to refract because it's going to move from more dense to less dense. Yes, very good, very good. So we're going to say water will now cause refraction as the light rays from point are going to bend in air like that. Is that clear, kids? So they have basically asked you the process. This is refraction. So you can write. In fact, if they've already asked this, we got to write a better answer actually, not this. We're going to say when the light ray changes medium, its speed changes. That causes a bending of the ray like that. And this process called refraction. Well, they asked this in the next part, so we don't want to bring that point in the first one. Is it clear, everyone? Now, when does a virtual image form? Can somebody please tell me that?
When it can't be formed on a screen.
Cannot be formed on a screen. The screen right now is our eye. And no, not about convex lens. It's not about that. The reason it would not form a real image because the rays from point do not meet at the eye. Do you guys understand that? Like this. Rays must meet at the screen. So that's why. Then, state the speed of light in air. Who's going to tell me this? This is pretty easy. Very
3
good,
into
Maha.
10 to the power of 8.
Very good, Vimos. Excellent. 3 into 10 power 8 meters per second. Do not forget units, okay? Units are extremely important. Very good. Now it says the refractive index of water is 1.3. Calculate the speed of light in water. Do you guys know any formula related to that?
The refractive index is equal to the speed of light in air upon speed of light in medium.
Speed of light in air or speed of light in medium. Okay. Can you please find the speed of light in the medium? Give me the answer, please. Everyone must be solving quickly. 2.3 times 10 power 8. You mean you have done it like this? 3.0 times 10 power 8, like Moss told us, divided by 1.3, and that's going to be 2.3 times 10 power 8. That's pretty good. Kids, excellent. Do not forget to write the units. Units have the the marks. All right, kids. Okay. Now that's pretty good. Very good, Hadia. Very good, Fatma. Tariq, Vipesh, Usman. Very nice. Very nice, everybody. You guys are very smart. All right. So sometimes what happens is that when these rays come, so it's not always a possibility that the rays that are coming from, let's suppose, a more dense to a less dense medium, they might be many rays, right? And if they're very close to the, they're very close to the critical angle. So what happens is that these multiple rays, some of them which are exactly at the critical angle might go like this, some of them might go out, and some of them just go in, right? This process that you see right here is called partial reflection. So we're going to write about it. What if they're same density? They would not bend then, because same density means it is the same medium for us. Oh yeah. Okay. So it means that then if multiple rays are incident onto a surface, some rays may get refracted and some reflected. This phenomena is known as partial reflection. All right, kids, like that. Please write this down, draw this. So just remember, this would happen if I is greater than C. This would happen with the ray that is exactly equal to C. And this is if it is even slightly less than C, it would go out. That's pretty important. All right. So write it down. Let's then check out what do we have next. Pretty good, pretty good. All right, kids. Should I go forward, please? What do you guys say?
So wait.
Just a second.
All right. Okay, Abdullah, that's very nice. Interesting.
Understood. Done. Sorry.
Very nice. It's very nice. So I'm gonna go to the next now. And let's check out this question. So in this question, it basically says that there's a red light traveling from air into prism made of diamond. Okay, that's pretty good. Very expensive prism then. The path of the red light is incomplete. So the refractive index of diamond is 2.42. What do you think X gonna be? Okay. This is a tricky one. Let's see how many people can do this. Whenever you guys are doing any question, always identify what is angle I and what is angle R. Then you're supposed to identify if it's going from a less dense to more dense medium or more dense to less dense medium. Think about it and solve this question. 18.5 All right. Okay. Let's see if there's somebody who thinks otherwise. 50. Okay. 50. All right. 15.4 degrees. Okay. All right. Mariam, I want you to answer, please. Hadia, Vad, Aisha, please wake up. Manur, very nice. Usman has done it. Okay. That's good. Okay, 15. Some people say it's 18, some people say it's 15. Okay. And also 50, which is highly unlikely. Okay.
Sir, I was just asking if 50 is the angle of incidence.
Yes, that's right. Hassan, wake up, please. Both Hassans. And Iman, come on, please. Do the work. All right. Okay. All right. Very good. Very good. Okay. Excellent. So some people are saying 15, some are 18. Okay. Fine. So there is a big fight going on between 15 and 18. So let's check it out. First of all, you guys need to realize this, that actually this isn't incident angle. In fact, incident angle is always drawn from the normal line, which means this is the incident angle. If this whole thing is 90 degrees, which means this is going to be 50 degrees. Is that clear, kids? Once you have the incident angle, because it's going from less dense to more dense, so sine I over sine R equals n. Sine I is going to be 50. We got to find sine R, n is 2.42. When you got this, then what you got to do is you just simply divide sine 50 divided by 2.42 and then shift sine once. And that's going to be 18. Why did you guys get 15? I'm surprised about that. Did you guys use 40 as the angle? Yes. So now please write a note here so you do not forget fact here that always take angle from the normal line. That's good. Okay. So Mariam, you haven't done this chapter before? And Moss, how about you?
Sir, I have done this chapter before in school, but I've never done it with so much detail. And also, I did not attend last class, so I'm not really aware with the sign calculations.
Oh, I understand that. But Mariam, you got to catch up. We have all the recordings stored, so you can catch up from those as well. If you have any problems, you can ask me as well. All
Okay.
right, kids. So we have basically made a breakthrough. We've learned that we will never ever take angle of incidence from other than the normal line. So that's what you guys need to remember. Now we got to explain the term total internal reflection. Everything that I wrote, you got to write exactly that. So this will be your homework. All you need to do is you go back, and you will see that I have written it is a phenomena when angle of incidence becomes greater than critical angle. This is when it occurs, right? And it is only possible when the ray is moving from less to more dense, right? So you guys need to remember this. Please write that and you will get full marks. Anyhow, the important question comes here when they say the angle Y is greater than the critical angle of the diamond. So draw a path of red light through and out of the prism after point A. So what you got to do is you got to go here. You got to basically, because Y is greater than critical angle, you will draw approximately a ray, which is using your ruler, that exactly depicts that it is equal to Y. It should be reflected. And when it hits here, you got to draw a normal line. Normal line is always 90 degrees. Now you got to think, do you guys think that the ray, this angle that you see here is greater than y or smaller than y? What do you guys say?
Smaller.
It is
Smaller.
smaller. Yeah, it is smaller. It seems like smaller, right? It is smaller, yes. If the ray is smaller, then obviously it needs to go out because it is going from diamond to, it's really y. This angle is y as well, right? So because this angle is smaller, it needs to go out. So you will bend it away from the normal because it's going from a more dense to less dense medium. Is it clear, everyone?
Yes, sir.
Yes.
Please write a note here as well. Draw the ray of reflection at the same angle as y, because reflection angles should be the same. Remember that. All right. Very good, kids. So now I hope you guys understand that. Please note down 226 is your homework. And now we're going to move towards what Hadia requested me to do. So Hadia said, we got to basically learn about how total internal reflection plays a role in different things. For example, the first thing we have is telecommunication, where we use optical fibers. Also, they're used in medical use. Anyway, so whenever you have optical fibers are basically, they take data from one end to another. So let me just give you a brief introduction. Optical fibers are made up of glass or plastic. They can carry light waves through total internal reflection to transmit data at high speeds. All right, kids. So you got to remember this. Now, when you see this drawing, they will always ask you to draw the next path. The first thing I would be doing if I was giving this exam, I would draw a normal line. Normal line is 90 degrees to the surface. So I'm just going to draw a normal line. And then I'm going to check what is this angle. Now, it needs not to be 100% accurate. But what you can do is you will draw a line that at least resembles this, like that. So it should look like that these are equal, just like that. Then you draw another normal line here, check the angle, mark angle I, and then move it this way. Then draw a normal line again if it hits the surface, and then move it this way. This way, you will keep on drawing I and R until it is out, and then arrows. Please do not forget about that. Generally, make sure there's straight lines. A lot of people try to use freehand. They're like this, and then they're like this. This is not a good way. Please use a ruler, okay, in the exam. So that would be good. All right. If you have any questions about it, please let me know. Now, the next thing is that we want to find the critical angle of this material. Can you help me find this, please? For 3.2? Why are you guys so quick? Okay, that's very good. Excellent job. Very good class. All right. Let everybody, Tarek, hurry up. Aisha, I want answers from you as well. Fraz, wake up, please. Ibad, hurry up. Usman, Mariam. Mariam has given the answer. Okay, that was Amna. Okay, and Hassan. All three Hassans, please. And Bipesh, quickly. Imaim, wake up, please. Abdullah, very nice. Very good. Very good, kids. Very good, Rabia. Excellent job. You guys are very smart, actually. It's very nice. Okay, so now that you guys have learned that it is sine C equals 1 upon n, so we're going to find C. We just need to divide it by 1.46. And you're saying that sine of inverse is 1 upon 1.46. Let's check it out. So use sine, shift sine. It's going to put it inverse, 1 divided by 1.46. And that's going to be exactly 43. Very good, kids. Excellent job. You can write 43 or 43.2. That's fine. Very nice, kids. Then you got to state two uses of optical fiber. I want to tell you the first use of optical fiber is telecommunication. That is high-speed internet. And it is also used in endoscopy. Endoscopy is a term that is used in medical. Yes, you're right, Fraz. And basically, you might have heard about a camera being inserted inside the body of a person through mouth or nose. And that's basically to see things inside. Decoration lights? Well, that's not a bad idea, actually. You can use it as a decoration light as well. But yeah, you could do that. You could do that as well. But not in physics, okay? In physics, we got to do these two things. Okay, Amna? Okay, very nice. Good idea, though. I'm going to put it in my office, though. Anyway, so then I'm going to go to the next. Now, I just want to basically here, I'm going to write up a couple of things. Let's see if I have given the medical use ahead. I have given the medical use ahead. Let me see for the telecommunication. So I'm going to write for telecommunication here, a small write-up so that in case they ask you this, you should know. So telecommunication. First of all, in telecommunication, light is faster than electrons moving in a metal wire. Number one. Optical fiber does not offer resistance nor gets heated up. It can transmit multiple pieces of information at one time. Then what you do is that it is much cheaper than a metal wire because it's made of glass or plastic, right? It's very cheap.
Sir,
Yes.
can you read point number 2?
Yes. Optical fibers do not offer resistance nor gets heated up. It can transmit. It can transmit multiple pieces of information at one time, much cheaper than metal wire, easily repaired and placed. All right. Then data cannot be easily leaked. So it's very secure. Like you can basically tap into traditional copper wires, but in these wires, it is very hard to do that as these contain light. Light does not create magnetic fields or electric field to do that. Is it clear, kids?
Yes, sir.
That's very good about it. So that is the reason nowadays, if you see, the optical fibers are used underground, like underwater as well, because seawater corrodes metals. It doesn't corrode this one.
Sir, what's the 6th point?
Data cannot be easily leaked, so it's very secure. All right, Amos.
No, what's the first word?
Data. It's DATA. Okay. All right. Should I go forward, please? All right, kids. So now we're going to talk about the reflectors of light. These reflectors, by the way, we know them. We have seen them all the time, by the way. You guys see it every day, probably. What happens is that basically, if there's a car behind, let's suppose there's a car which has its headlights on, but then there is another car in the front. But this car, the issue with this car is that its backlights do not work. If backlight do not work, they place certain reflectors on it. What does these reflectors do? They're created from plastic. So the light rays from the car behind basically comes in to these reflectors. They get totally internally reflected inside. So you only need to learn the diagrams and then gets reflected back because of this, like that. Oh my goodness, that's unfair. Like that. So they basically are placed at 45 degrees. So they come in, gets reflected, and then go like this, go back to the same car. So that basically causes the car that is behind this to see if there's something in the front. Like that. So they're all at 45 degrees, all angles. Okay. If you don't know about it, I'm going to show you this. Wait a second. You can draw this.
Is this the last thing we do today?
Probably not. We
Okay.
have a lot of time. Car reflectors. Okay. Enter. So these are like this. You might have seen these on bikes as well.
Bicycles too.
Yeah, bicycles like these. You know? Exactly these things. Okay. So these are there just to make sure that if there's something, ahead of a car, the car can see the lights don't function well. Yes, they're on runways as well. That's right. They're on normal roads as well. I've seen those as well. Now, in this one, you just need to remember that only the diagram is important. Nothing else. No write about it. Okay. Then we are going to go to the next and we're going to talk about the optical fiber use in medical. First of all, who's going to tell me what is this process? What's happening here? Quickly, please.
Total internal reflection.
Yeah,
Internal
guys.
reflection.
Total internal reflection. Very good, kids. Then it says calculate the minimum angle I. For these I, there will be no retraction at point P. How do I know that? Oh, yes. What would be the minimum angle,
The critical
not
angle.
critical angle? Can you explain the critical angle, please?
45? Will it be
45?
45? Yeah.
All right, everybody, please. Let's see what others. Let's take a unanimous thing. 46,
0.6.
45.
Yeah, 45.6.
Yes. Yes. What it answer now? We got to just or say shoot for
Sir, you're
five. You have
lagging.
to round it.
Sorry, your voice is high.
That's bad. Today my internet is working not right. I know what happened. That's all. One is so important. I wanna go on. Okay, wait. Let me make a switch over. Desperate. Oh,
Sorry, your screen is frozen.
yeah, not on that. I'm changing the camera that it's not frozen.
It's sorry to interrupt, but it's even more difficult to hear you now.
I understand. Wait a second, please. Come on. Oh, is it okay now, kids?
Yes, sir.
Yes,
Okay,
sir.
very bad. All right. So now critical angle you said like last time it was 45. Let's check. So sine C equals to 1 upon n. C will be sine of inverse 1 over 1.4. Now, when you're getting an answer of 45.58, you got to round it up. You can't write 45 because there's 0.5. You should round it up. Is it clear, kids?
Yes, sir.
Okay. Let me just put it through screen sharing. I didn't do that. That's bad. Okay. Mhm. Wait a second. All right, kids. That's good. Now, then we're going to write this important piece of information about the use of optical fiber in medicine. So please check this out. Please write this right up. I'm going to say endoscopy is carried out by inserting a camera or light and reflective device connected to an optical fiber. The light then reflects from the organs and boundaries into the optical fiber. Doctors can view the image as light comes back through total internal reflection. All right, kids, like that. So this would be the perfect write-up for this. If you have any questions, please let me know.
Sir, isn't there a tool like connected to it to cut or something?
Yes, you don't need to cut anything. This is basically endoscopy is a non-invasive technique. Non-invasive means that you are not cutting anything, all right, into the body. You're just inserting something. Is that clear?
Yes, sir.
Okay.
Done.
Okay. Right.
Let's move on.
Okay, very nice. You seem like in a hurry. Why, Mushk? You have to go somewhere.
Yes, there's something I need to get done. But no, it's okay.
So the light shown is monochromatic. Now I want to tell you what this word means. Mono. Mono means single. Chroma means color. So it means light of single frequency. This is what monochromatic means. So what do you guys say? What would be the answer then?
That it's light of one frequency.
Yes. Light of a single frequency. This is something. If they give you, you can also write wavelength instead of this, but the wavelength option is not here. So you are not supposed to write that. So you're going to pick this one. Okay. Now, moving forward to the last one, which is the periscope. The periscope is basically a sort of a device that helps the viewer to see objects above his or her height. Okay. Now, yes, it is used in submarines. You're right. You're right. You might have seen those. You know the movie that was on I think it was Ice Age or something like that. They used to have that. Yeah, that's good information. So when you draw the diagram, again, the diagram is needed. Like what you do, you continue the ray straight, you hit it right here, then you draw the normal line, draw angle I, then continue it down, draw angle R, hit it here, move towards the eye. It is all you need to do. There's nothing else you need to do except for the arrows that you need to draw so that you see where the ray is going. Then it says, show that the refractive index, show that the critical angle. So this I'm going to give you as homework because now we have practiced it enough and you guys need to do it on your own. Finally, we are done for today's work. When we meet each other tomorrow, we're going to work on the optics. If you guys have anything more to ask, we'll see you. So, all right. Yes, it is. All right. See you kids. Have a nice day. Bye.
Question.